Right, now in this question, two substances of dielectric constant K1 and K2 are equally put in between the sheets of a parallel plate capacitor with a separation D. Find the equivalent capacitance of this setup. Right. So to do this question, we need couple of equations. First one will be, we need to know the capacitance of a parallel plate capacitor. A epsilon naught over D. So here, capital A is the common surface area, this one, and epsilon naught the medium inside, and D is the separation between them. So there's another data, uh, dielectric constant K equals epsilon divided by epsilon naught. Right. Other than that, we need another equation. When capacitors are connected in series, we add them, this C1 and C2. So in series, we have to add them 1 over C1 plus 1 over C2 equals 1 over C is the equivalent capacitors. And if these two are parallel in this way, here C1 and C2 we can directly add them, so C1 and C2 equal to the equivalent capacitance. Right, now in this equation, let's get into the question. So here, what initially we need to check, so these two are the parallel plates, say C and D, these two are the parallel plates, so a cell will be connected in between like this. Right, now you can see this is the same cell, it's the same cell, same plate. Right, so the potential here, let's say this is V, here it will be V, and here the same potential. So what we can see here is these two capacitors, say C1 and C2 capacitors, are parallel, connected to the same potential here, same potential, same potential, again same potential, same potential. So it's almost like two, it's two parallel, exactly the two parallel capacitors, right, C1 and C2. So we can directly add them. So what we have to do is we have to find the capacitance of C1 and C2. So let's apply the basic equation A epsilon naught over D. So here common surface area will be A by 2, and epsilon naught, actually it's now K1 epsilon naught, and the separation between them is D. For the other one, of course, again A by 2 K2 epsilon naught divided by 2. I can directly add them because these two capacitors are, you can see, in parallel. Right. So I'll take common A epsilon naught and 2D out. So I am getting K1 plus K2 here. So you can see the answer among these answers. It's the second answer. You can see here in this playlist, actually electric field phase, you can see capacitor questions, so you can go through these questions and you can do these questions as well. So if you think this is helpful, share it with your friends, study together and win together.